A very good morning to all our distinguished guests, esteemed staff members, respected researchers, and our promising young minds. It's my distinct honor to welcome you all to the 4th Undergraduate Research Symposium on Agricultural Engineering and Environmental Technology, URSAE 2025, hosted by the Department of Agricultural Engineering and Environmental Technology, Faculty of Agriculture, University of Ruhuna. We are gathered here today under the resonant theme, Smart Roots, Engineering Innovation for a Greener Planet, a vision that bridges foundational knowledge with the future of sustainable technology. A special and heartfelt welcome to our distinguished keynote speaker, Professor Kuroki Shinjiro from the prestigious Kyoto University, Japan. He leads pioneering work in biosensing and non-destructive technologies to diagnose plant health and reducing post-harvest losses. Sir, we are truly great to have you here with us today. We shall now commence our formal proceedings. I request everyone to join us in a moment of academic pride and tradition as we present the university anthem.
Babalana sirilaka dakune Niruvan pirikala terane Panuvan oradunu porane Sarasaviyai merune Sarasaviyai merune Vidya Shilpa Kala dan Haravat Labamin Danamana Karamin Panavat Desa Basa Rasa Surakina Oda Tedavat Minisun Vemuro Pasasana Gunavat Babalana Sirilaka Dakune Niruvan Pirikala Terane Panuvan oradunu porane Sarasaviyai merune Sarasaviyai merune Yuktiya Shaktiya Bhavaniti Sihikara Dagot Kulamala Patumata Pindahara Namaraka Parasindu Rohana Puravara Hiru Sandu Vemulak Sarasavi Nilambara Babalana Sirilaka Dakune Niruvan Pirikala terane Panuvan oradunu porane Sarasaviyai merune Sarasaviyai merune
The journey to URSAE 2025 has been shaped by remarkable commitment and vision. To officially integrate this intellectual gathering, it's my distinct honor to invite Dr. Tusita Bandara, the coordinator of URSAE 2025, to deliver the welcome address. Over to you, sir.
Our distinguished keynote speakers, the Dean of the Faculty of Agriculture, University of Ruhuna, Professor G.Y. Jayasinghe, the Head of the Department of Agriculture Engineering and Environmental Technology, Dr. M.G.G. Avanti, respected session chairpersons, esteemed academic and non-academic staff of the Faculty of Agriculture, research supervisors, and internal and external institutions, colleagues, and dear students. Good morning to you all. On behalf of the organizing committee, it's my great honor and pleasure to welcome to you all for the 4th Undergraduate Research Symposium on Agriculture, Engineering and Environmental Technology, organized by the Department of Agriculture, Engineering and Environmental Technology, Faculty of Agriculture, University of Ruhuna. Today marks a significant milestone as we celebrate many years of fostering research excellence among our undergraduate students. Over the 4 years, URSAE has grown into a recognized academic platform that brings together researchers, academic, professionals, and students to explore solutions to pressing challenges in agriculture and environmental sustainability. This year's theme, Smart Route Engineering Innovation for Greener Planet, reflects collective commitment to developing sustainable technology-driven solutions. The research presentations today span for 4 dynamic thematic areas: climatic resilient systems and sustainable design, smart automated agriculture technology, environmental intelligence and resource management, greener innovations for circular economy. I extend a very warm welcome to our distinguished keynote speakers whose presence greatly enriched this symposium. We are honored to have Professor Shinichiro Kuroki from Kyoto University, Japan, deliver the main keynote address. We also warmly welcome our session keynote speakers, Professor BHN Rasan Pripabe, Associate Professor, University of Rikyos, and Engineer Indunil Subhashana, Project Manager at AI Grow Private Limited, and Electrical Engineer Viga Innovations, Professor Dari Roy, Professor of Science Foundation, Philippine Normal University, Manila, Dr. KPP Udayagi, Senior Lecturer, Department of Biosystem Technology, Faculty of Technology, University of Sri Jayawardena. We are deeply honored by presence of Dean of the Faculty of Agriculture, University of Ruhuna, Professor G.Y. Jayasinghe, whose leadership and continuous support for vital role in the strengthening undergraduate research and academic excellence within our faculty. We also get pulled to our head of the Department of Agriculture, Engineering and Environmental Technology, Dr. MGG Avanti, for her guidance, encouragement and dedicated support in organizing, sustaining this symposium. I would also like to sincerely acknowledge our session chairpersons for guiding the technical discussions and ensuring the academic quality of this symposium. To our research supervisors from both internal and external institutions, thank you for your mentorship and dedication. The quality of this research presented today is true reflection of your commitment. To our final year students, this is your moment. You have worked diligently, navigated challenges, and produced research with real-world relevance. Be confident and proud and make the most of this opportunity. I also extend my appreciation to the organizing committee for their tireless effort in making URSAE 2025 a success. As we proceed, I encourage everyone to engage, actively ask questions, share perspectives, and build meaningful connections. The true value of URSAE lies not only presentations, but also the ideas, collaborations that engage throughout the discussion. Once again, I very warm welcome URSAE 2025. I wish all the presenters very success. Hope you all productive, inspiring symposium. Thank you very much.
Thank you, sir, for that gracious and insightful welcome. Now it's my privilege to invite Dr. Avanti Mahanama, the head of the Department of Agricultural Engineering and Environmental Technology, to deliver her address. Over to you, madam.
Good morning, everyone. Senior Professor G.Y. Jayasinghe, Dean Faculty of Agriculture, University of Ruhuna, Professor Shinshio Kuroki from Kyoto University, Japan, our main keynote speaker today, and other keynote speakers, staff members, colleagues, and dear students. It is a pleasure to connect with you all of you virtually for the 4th Undergraduate Research Symposium on Agricultural Engineering and Environmental Technology, we called as URSAE 2025. As the member of the department, I am truly happy to see these activities organized by our department. While our department organizes many programs for different target groups, our students always come first. It is our priority to create platforms like URSAE that focus especially on our professional, it means especially students' professional and academic development. URSAE began as a platform for undergraduate students to present their final year research. As Dr. Tosita also mentions, over the years, it has grown into a meaningful forum that builds innovation and professional confidence. As we gather for this 4th edition, it is encouraging to see how this initiative continues to strengthen the research culture with our department. This year's theme, Smart Roots, Engineering Innovations for Greener Planet, is incredibly relevant to the time. It reminds us how this work in agricultural engineering must be firmly rooted in sustainability. And also I would like to address our students, especially dear students, conducting research and presenting it is both valuable experience and great opportunity to develop your skills. You should be proud of the effort you have made today, as this marks an important milestone in your professional journey. I also want to thank our academic staff and supervisors. Your mentorship is what makes this high standard of research possible. Before I conclude, I must express our sincere appreciation to those who made today's possible. First and foremost, a heartfelt thanks to Professor Kuroki Shinshiro. Dear Sensei, we are truly honored to have you join us from Japan. Your international perspective is a gift to our academic community. I also thank our other keynote speakers and session chairpersons for their valuable contributions. My appreciation goes to organizing committee and the volunteer working behind the scenes to make this online symposium run so smoothly. I hope today's event inspire you to continue your research journey for the betterment of society and the environment. Finally, I wish URSAE 2025 every success and hope it will be an inspiring experience for all. Thank you.
Thank you, Madam, for that inspiring words. The Faculty of Agriculture provides the fertile grounds for groundbreaking innovations to sprout. To enlighten us with his wisdom, it's my privilege to invite Senior Professor Gutilugantha Jayasinghe, the Dean of the Faculty of Agriculture, University of Ruhuna, to deliver his address. Over to you, sir.
Yeah, good morning and good day to you all, and distinguished guests, especially our keynote speakers, Professor Kuroke and Professor Baum, and then Daryl, and all these respected members and members of the organizing committee, and the fellow academics, and dear colleagues and proud parents, and as well as finally my dear undergraduate students. So as the Dean of the Faculty, it is my privilege to welcome you all to the 4th consecutive Undergraduate Research Symposium on Agricultural Engineering and Environmental Technology, URSAE 2025. So it is an important academic activity of our faculty, and it reflects our collective commitment to research-driven teaching, innovation-led learning, and national relevance. And as well as I commend the Department of Agricultural Engineering and Environmental Technology for sustaining this symposium with dedication and the academic rigor for the fourth consecutive time as well. So this URSAE established 4 years back with a clear objective. So to provide undergraduate students with a structured and professional platform to present their research and the defend ideas and engage in scientific dialogue. So this symposium is not just merely a presentation forum. So it is a training ground for analytical thinking and scientific writing and communication, ethical research conduct, and evidence-based problem solving. So over the years, URSAE has grown in quality and scope, and the research presented today demonstrates increase in originality, novelty, and technical depth and relevance to the real world challenges. So that is what we are always calling 21st century challenges as well. Now let's look into this year's theme as well. So that is Smart Roots, Engineering Innovation for a Greener Planet. So captures the academic direction we wish to promote as a faculty. So what is that SMART? It reflects the responsible use of data analytics, digital transformation, automation, artificial intelligence, digital monitoring systems, and engineering optimization tools. So let's check it out. What is the roots? Roots remind us that innovation must remain grounded in the areas of ecological sustainability, natural resource conservation, community needs, and long-term resilience. So our expectation is clear. Engineering solutions must be technologically advanced, environmentally sound, and socially responsible. So that is where we are calling sustainability. So all this research and as well as our program is in line with the SDGs. And the symposium strongly align with this our faculty academic philosophy as well. So let's have a brief overview of these main sessions. So as Mandara and Avanti mentioned, URSAE is structured around 4 key thematic sessions, and each addressing critical national and global priorities. So first one, the climate resilient systems and sustainability. So that is focusing on resilient infrastructure, renewable energy, sustainable materials, and smart irrigation designs. And next, smart and automated agricultural technologies. So highlighting machine learning applications, now where it is happening around the globe in extensive ways, and UAV-based systems, unmanned aerial vehicles, and IoT-enabled devices and precision agricultural tools. So we do have a challenge to increase the food production. So therefore, we need to get the maximum use of these existing resources as well. In third session, environmental intelligence and resource management. So that is addressing flood information systems, water quality monitoring, blue carbon assessment, and waste to resource technologies. And next one is the green innovations for a circular economy. So that is showcasing bio-waste reuse, eco-friendly materials, sustainable product design, and green entrepreneurship concepts. So you can see it is timely, and it is going to cover entire area of this technology paradigm. Together, these sessions reflect the interdisciplinary and solution-oriented nature of modern agricultural engineering and environmental technology. So, and again, always I'm talking about this alliance with the global priorities and as well as the national priorities. So, these research presented in URSAE 2025 clearly align with the Sustainable Development Goals, that is SDGs, and climate change adaptation and mitigation strategies, that is Paris Agreement related activities, and national priorities for food, water, and energy security. And finally, environmental responsible engineering practices. So for a country like Sri Lanka, highly dependent on agriculture and highly vulnerable to climate impact, so recently we've been experiencing, such research is not optional, it is definitely essential. So to our undergraduates, so undergraduate researchers, right, early career researchers, I wish to emphasize them. Your research should move beyond description. It must demonstrate clear problem identification, critical thinking, sound methodology, digital transformation, critical analysis of result, and practical applicability. So undergraduate research is a foundation for discipline, scientific integrity, and professional responsibility. URSAE provides you with an opportunity to experience these standards in a formal academic environment. So then I want to sincerely acknowledge the head and the academic staff of the Department of Agriculture, Engineering and Environmental Technology, the organizing committees, reviewers, judges, keynote speakers, and all well-wishers and distinguished members and members in local and a lot of global participants, international consortiums, and all academic and non-academic staff who contributed to the successful organization of this symposium. Your efforts are vital in strengthening the research culture of the faculty. So I am thinking to give some strategic direction, because now this is we are going with this 4th time. So before concluding, I wish to outline an important forward-looking direction. So while URSAE has been successfully established as an undergraduate symposium, its future should not be should extend beyond undergraduate research alone. So I strongly encourage the future organizing committee, invite researchers from outside the department within the faculty, engage researchers from other faculties and the universities, include postgraduate and early career researchers, and create opportunities for interdisciplinary and industry engagement. So I'm always talking about a university industry platform. The challenges addressed through this URSAE 2025, climate resilience, sustainable agriculture, environmental management, cannot be effectively solved within disciplinary or institutional boundaries. So therefore we need to remove these all barriers as well. URSAE should gradually evolve into a broader, inclusive research platform while retaining its strong undergraduate foundation. Such an evolution will enhance academic vigor, academic exchange, research quality, and national visibility. So finally, URSAE 2025 represents both achievements and the opportunity. Achievement in sustaining a high-quality undergraduate research forum, and opportunity to further strengthen collaboration, innovation, and impact. And I encourage all participants to engage actively, exchange ideas constructively, and uphold the highest standards of academic professionalism throughout this symposium. I wish the organizing committee, presenters, reviewers, and all participants a highly successful and intellectual rewarding URSAE 2025. Thank you all. Have a good day.
Thank you, sir, for your invaluable guidance and unwavering support for this endeavor. And now it's my distinct honor to invite Dr. B.M.S. Jinendra, Senior Lecturer from the Department of Agricultural Engineering and Environmental Technology, to deliver the citation of our keynote speaker, Professor Kuroki Shinchinora, honoring his exceptional legacy. Over to you, sir.
Very good morning, ladies and gentlemen. So it is with great pleasure, let me introduce our keynote speaker, Professor Shinichiro Kuroki. Professor Shinichiro Kuroki is a professor at the Graduate School of Agriculture, Kyoto University, Japan. At present, he is leading the Laboratory of Biosensing Engineering. His research mainly focuses on non-destructive evaluation, post-harvest engineering, sensing technologies for plant physiological status, with the integration of optical spectroscopy, hyperspectral imaging, nuclear magnetic resonance, and he also expert in applying machine learning tools for the rapid detection of natural efficiency and freshness of fruit crops. So he earned his bachelor degree in agriculture engineering from the Faculty of Agriculture, Kyushu University, Japan in 1999, and followed by his master's degree in bioproduction and environmental science from the same university in 2001. In 2004, he obtained his PhD in agriculture from the University of Tokyo, Graduate School of Agriculture and Life Sciences, specialized in biological and environmental engineering. Professor Kuroki has authored more than 60 peer-reviewed journal articles with over 870 citations with an H-index of 12 and has contributed several book chapters in the field of agriculture machinery, food engineering, and post-harvest technology. Professor Kuroki holds several patents for innovation methods and devices, showing his excellent contribution to the rapid and non-destructive measurement of food quality attributes. His work has shown recognized both academic and research and industrial application, bridging fundamental plant science into real practical level application in the precision agriculture. So beyond his academic achievement, he plays an active role in international research collaboration through his student exchange program, capacity building programs, and he works closely with universities in Vietnam, Thailand, Indonesia, and Sri Lanka by secured fund through competitive grants. So at this point, I would like to gratefully acknowledge his contribution, significant contribution in organizing a Sakura Science program and inviting Sri Lankan undergraduates to have international training. So today he is going to further strengthen the close bond between our two institutions by accepting our invitation to deliver the keynote address. So today he is going to talk on how to interpret post-harvest quality deterioration through water dynamics. In his talk, he is going to propose a novel framework for better understanding quality deterioration in horticultural products for improving storage strategies while reducing the post-harvest losses. So may I kindly invite Professor Shinichiro Kuroki, sir, to deliver your keynote address. Thank you.
Thank you for much your introductions. Thank you very much. So can I share this slide? I can't hear you. Can I share the slide? Yeah. Oh, can I share the slide? Can you see the slide? I can't hear anything from your side.
Sure, sir, you can share the screen.
It's okay. It's ready to
We can
start.
see, sir.
Okay. So may I start? May I start my presentation?
Yes, sir.
Okay. So first of all, I would like to express my deepest gratitude to Dr. Jindra. He's one of my best friends. So thank you very much for this kind of great invitation. And also, I want to express my gratitude to the committee of the URSAE 2025. I hope this symposium will be the great one. So today I would like to explain about interpreting post-harvest quality deterioration through the water dynamics by explaining about my researches. Okay, so have you ever seen this type of graph? So horizontal axis indicate the fruit and vegetable consumption per day, gram per day. Then vertical axis indicates the relative risk for the coronary heart diseases. So as you can see that if you take the 350 grams per day of the fruit and veggies, the risk of the heart attack will be decreased. So this is a clear evidence that human beings need fresh fruits and veggies. So there are several trials or several campaigns that, as you can see, this fruits and veggies has colors. So the color indicates such kind of the healthy components. So it will be the great resource to keep in our health and diet. So that's why I just explained about the United States, England, and Japan, Korea, and some other country that they need some priority to take the fruits and veggies. For example, United States, the half of the plate should be occupied by the fruits and veggies. Like in the in the other countries too. So this is the almost all countries' government recommends to take the fresh and fruits and vegetables. Okay. So, sorry. So, if you, especially for the undergraduate student, let's join this quiz to take this QR code to access through your smartphone. So, what do you think about what is the Sri Lankan global ranking in per capita vegetable consumption per day? For instance, Ukraine is 26th, then the United States is 64th, then the Chad is the last at 186th. So what do you think about that? You can vote, I guess. No vote? I want to get some interactive presentations. Anyway. So, I don't know. I don't know about your interview. I cannot get anything from your response, but I unfortunately, no response. There's no. It's impossible to access this slide through the Sri Lanka. I don't know. Okay, let's move on. So unfortunately, your country is graded as a 113th out of the 186th. So the recommendation is per day is 350 grams, but your consumption is more less than probably 250. So what about this graph is the trend in the daily per capita vegetable supply in Japan. I'm so sorry about it's impossible to get the data in your countries, but in Japan, the consumption of veggies is decreasing with time. Then, keeping the health is very serious issue in Japan too, I guess, in the future especially. So the next question is a similar one, but the ranking in the fruit consumption in Sri Lanka. So same as the fruits and veggies, your ranking was 150, and it's very lower grade of the consumption rate, amount of the fruits. So, sorry. In the similar way, in the Japan's cases, the fruit consumption is below the 200 grams is the recommendation of the consumption amount. Then it's not increasing right until now. But as I explained about at the beginning, we need fruits and veggies to keep our health. So to eat the fruits and veggies more, they need to stay fresh more. So how can I stay fresh? And why do the fruit and veggies wilt? And how does it happen in the inside? So this is my research question in several decades. So I'm explaining about these things from now. So water, and not only the water but gases, moves inside the plant. So as you can see on the right hand, the water or gases moves from the outside, from and to the outside into the mitochondria or the chloroplast or something. Okay, so there are several resistance to pass through the inside the tissues, but they moves inside the plants. Then, especially their pathway is regarded as the intercellular spaces. So do you know the intercellular spaces? What is it? So intercellular spaces is the spaces between the cells. So when the cells is enlarged with as the to be big, as you can see on the slide, edge of the cell is like like get a curvature, then we can find this kind of the space is observed. So this is so-called the Shizuku generous interstellar spaces. And the more big one is some some cell death has happened, then a relatively bigger interstellar spaces observed. So which is a least generous interstellar spaces. So interstellar spaces is filled with gas or liquid, but hydrophobic molecular layer is presented on the surface of the cell wall. Then most of the interstellar space is filled with gas, but which is it's a kind of the myth. Then interstellar spaces is it's very difficult to measure the which is filled, gas or liquid. So then, but still, interstellar spaces, especially for the gas-filled interstellar spaces, has this kind of the special function for the plant physiology, like gas transport or light scattering and buoyancy in the water, releasing the seed and pores and gas trace of something. So this indicates that spatial structure itself relates to the light activity. So, but it's very difficult to observe the interstellar spaces. So this is I made it this microscopic image by hand cut sections of the cucumber fruit. So probably if you have the very huge experience to observe this kind of microscopic images, you can find something about okay, where is the interstellar spaces, but it's not possible to think about this kind of the volume 3D rendering structures and how much is the gas field and the liquid fields. So that's why we need some other technique. So one of the good way is to use the X-rays. So since X-ray travels in straight line, they follow the Lambert-Beer's law. So we can calculate that the density of the tissues where the X-ray pass through. So like if you take like this image by using the X-ray, so the projection number would be like this. Then you can change the angle from the X-ray irradiation, then like to 445 degrees, and 90 degrees, then 135 degrees. So okay, if you get this kind of the projection data, we can reconstruct the original images by the back projection, like this. Okay, then you can do the back propagation to them. Then we projected the 4 times in this case, so we can do the averaging the 4. Then it will take this kind of the images, so which is not completely true, but it's still there is some relative relationship can be found in this back projection image reconstructions. Okay, using this technique, X-ray CD, especially for the micro CD images, can be visualized interstellar spaces in the tissue. So let's move on to the result discussion. So this is a transverse sections of the cucumber fruits. So this this outside the black area is the background. Then inside the black area, like here, and here, like that, where is the lower density. So that's why this is interstellar gas-filled interstellar spaces inside the tissues. Then the other area, like a gray or white area, is indicating the higher density. That's why it will be the cell or some others. I mean, it's composed of the liquid and solid materials. Okay, so you can see. Okay, I will show the video. So if this slice moving up like that, you can see this shape of the black part is changing. Okay, so this is okay. So this is very difficult to imagine, but I can show you some good way to visualize those structures. First, we clustering based on the volume voxel intensity, then classification, then shading and recasting. This kind of volume rendering technique can be applied to this the video I showed you before. So then we reconstruct the intercellular spaces like this. So green colors indicates the intercellular spaces, and the other point is the cell. So, okay, as you can see that intercellular spaces, especially from the gas-filled intercellular spaces, is spread in broadly inside the tissue. Then some other part is not isolated. It's not isolated. It is connected to each other. They show the very complicated network, which is the pathway to the gas and water gaseous phases into the tissue. So when we calculate the change in those kind of the sizes of the gas-filled intercellular spaces between day 1 and day 5 of the stretch, the bigger sizes of the gas-filled intercellular spaces is dramatically decreased. In contrast, the smaller volume of the gas-filled intercellular spaces increase. So this result indicates that with aging of the biological membrane over time, intracellular water inside the cell is leaked into the outside the cell to the gas-filled intercellular spaces. Then gas-filled intercellular spaces is blocked, fragmented each other like this way. The red one is the root pathway to the gas as pathway, which is the gas can go through like this way, but the water is blocked. So like a highway, under construction, right? So it's very difficult because gas diffusion in the liquid phase is 10,000 times slower than the diffusion in the gas. So it will be makes the gas diffusion slow. So the apparent gas transport pathway becomes wrong. So, okay, if this observation is true, if this is truly happen inside the tissues, so the effective diffusion coefficient, diffusivity should decrease. So we need to get this kind of that evidence by using the gas chromatographies. When we apply to the neon gas, which is the inert gas, which is not consumed, it is not disappeared. Then if we packed the cucumbers with the neon gas are surrounding the cucumber, diffuse into the cucumber. So that's why if we can measure the neon gas concentration in the atmosphere with time, we can get how much neon gas is easily or difficultly diffused into the cucumber fruits, which is the diffusion coefficient. Okay, so we set this phenomena of the diffusion equations. Then by using the initial and boundary condition, then we can solve this phenomena. So the results show that day 1, the very fresh state of the cucumber, diffusion coefficient has a 5.2 multiplied by 10 power minus 9 levels of the diffusion coefficient. But after 5 days, it decrease. So this indicates that diffusivity decreasing, which is evidence that this kind of the decrement of the diffusivity occurred probably by clogging the water leakage from the inside the cell to the gas-filled intercellular spaces. So we solved this problem, but we need to solve the problem with why the gas exchange rate changes with the time. So this is a very famous phenomenon that when we measure the respiration rate, gas exchange rate of the fruits and veggies, except for the climacteric fruits. Their respiration rate decreases with time by like aging, right? So is this decline is because of the reduction of the gas transport rate, as I showed the result in before, or the other reason, like the gas reaction rate? So this kind of the phenomena can be expressed by the reaction diffusion equations. So then, especially we assume that this reaction item is expressed by the Michaelis-Menten equation types. So, given the form that reflects the gas concentration dependence by the Michaelis-Menten type of the reaction, then as for the reaction part, then as for the diffusion part, the cucumber is like it's possible to assume the cylindrical shapes. That's why we define the spatial coordinate system in the cylindrical coordinate. Then we can solve these partial differentiations with then to get the parameter to applying in the measured values. So this graph shows the gaseous environment inside the cucumber fruit, which is simulated ones. So horizontal axis indicates a non-dimensional position, which is, I mean, the 0 indicates the center of the fruit of the cucumber. Then 1 indicates the gas skin surface of the cucumbers. So there's a gradual decrement as the close to the center. The oxygen concentration is decreasing. But because of the change in the diffusion coefficient, as I showed you, day 1, just after harvest, one day after harvest, have the internal oxygen profile is like this kind of the green curve. But after 5 days, the diffusivity is decreased. That's why the oxygen concentration profile inside the cucumber decrease like the yellow line. So, but unfortunately, this kind of the decrement of the diffusivity can explain only the 15% of the decline of the gas exchange rate. In other words, the rest of the 85% of the gas exchange rate decline cannot explain not only by the diffusivity. So this graph indicates the relationship between the oxygen concentration and reaction rate. So as you can notice that at the increment of the days after harvested, the reaction activity decline markedly. So this would be the substrate or enzyme concentration or activity become less and less as the time goes by. Then those will be the rate limiting factor. So with combine this result, that's okay. The diffusion is decreasing, but not possible to explain everything. And reaction rate itself decrease as well. So let's combine them to explain about the whole phenomenon. Then, so the gas exchange rate at 1 day after harvest having the 1.75 multiplied to 10 power to minus 4 mole per cubic meter per second, but this will decline to 7.53 like that. So this decline is experimental observed. Then the diffusion coefficient of the oxygen is decreasing, of course, as I showed you. Then, but the reaction rate is Km is a Michaelis constant, so-called. But this indicates the concentration of the maximum rate in the half concentration. Anyway, if this value is low, this reaction rate is high. So we can get this Michaelis-Menten constant is increasing, then the reaction rate itself is decreasing markedly over time. So we can clarify that the change in the gas exchange change rate can be explained by the decline of the reaction rate and as well as the decline in the diffusivity. I mean, not just explained by the diffusivity, and not just describing by the reaction rate itself, which is a combination effect of the both phenomena. So those parameters, for the clarification of those parameters indicates that straight condition should be designed considering both the gas transportation and gas consumption rate inside the produce together with their time dependence, which is not the constant over time. So we can probably, you have to think about the dynamic control of the gas concentration or some other environmental control to keep freshness more and more to stay more fresh more. Okay, so this is a kind of the graphical abstract which is made of my colleague that as you can see on the upper side of the this graphical abstract, 1 day after harvest, gas exchange rate can be explained by the like a truck transportation of the oxygen to the factory of the ATP generating factory in the mitochondria. Okay, those kind of the speed is decreasing by the clogging of the root by the liquid infiltration into the gas filled intercellular spaces. Then not only the root stacks, but also the factory mitochondria in the mitochondria. Those reaction rate is also decreasing. That's why the ATP generation is decreasing. This is the aging, or this is the deterioration of the cucumber fruits after post-harvest stage. Okay. So that's all my presentation today. So thank you for your attention, and I hope that my presentation makes you happy. I mean, it makes you interesting. Then help you to interpret the post-harvest quality deterioration through the water activity. That's all for my presentation. Thank you very much.
Now the floor is open for a Q&A session conducted by the Professor Kuroki Shinshiro. Over to you, sir.
Thank you very much, Kuroki Sensei. Now, you open up a complete new dimension about how to detect the deterioration of freshness by using these molecular water activity dynamics. So I have a little concern about the cucumber fruit and their exchange capacity will change due to their growing stage. And then now if you harvest little early, so how that will affect on this the exchange maybe than the later harvested one, right? Maybe 2-3 days later. So then how can we interpret this with the real cell level some changes due to freshness, and as well as this growth due to the changes of exchange due to this growth stage differences?
Thank you very much for your question. So yes, this is a very good viewpoint to understand this kind of the research. So especially in Japan, we love to eat a younger age of the fruits. That's why the cucumber fruit is harvested on the 100 grams, then with the 20 centimeters long. So, but compared to the Japan, the other countries harvest the cucumber a little bit more grower stage. That's why the respiration rate and probably the the structure inside would be different from the Japanese cucumbers one. Not because of the variety, but because of the like a growing stage, as you said. So that's why the probably the cucumber fruit in your country is older than our one. So the reaction rate would be a little bit slow. That's why I guess the diffusivity effect is much greater than the younger one. So probably the water leakage from the inside would be some other probably significantly bad effect on to keep the freshness in the cucumber fruits after harvest. Those kind of relationship can be found in your country.
Okay, thank you very much. So then the model and the methodology may be slightly modified to match the situation, right?
Should be, but still, if you can observe this difference in the parameters of our model, can be explained about why those difference can be observed. I guess.
Yeah.
Thank you very much. Thank you very much for your great questions. Thank you very much. Okay.
A profound thank to Professor Kuroki Shinjiro for that insightful and enriching session. The intellectual core of URSAE 2025 is the novel research contributed by our undergraduates. To mark the official commencement of these scholarly exchanges, I would like to invite Dr. Praneeth Ruwanpatirana, the editor-in-chief of URSAE 2025, to present the symbolic unveiling of the URSAE 2025 proceedings.
Good morning, everyone. Distinguished guests, colleagues, and all participants. It's a great honor to address you today as the editor-in-chief of the URSAE 2025 proceedings. Over the past 4 years, URSAE has served as a valuable platform exclusive for undergraduate students of the Faculty of Agriculture, University of Ruhuna, enabling them to present their research and gain early experience in scholarly communication. URSAE 2025, held under the theme Smart Roots, Engineering Innovation for a Greener Planet, highlights the creativity, innovation, and scientific thinking of our undergraduates. The e-proceedings bring together the outcomes of their final year research and mark an important first step into academic publishing. On behalf of the editorial board, I sincerely appreciate the contributions of the authors, reviewers, and the organizing committee for their dedication to maintaining academic quality and integrity throughout the editorial process. At this moment, I respectfully invite Senior Professor G.Y. Jayasinghe, the Dean of the Faculty of Agriculture, University of Ruhuna, to officially launch the URSAE 2025 e-proceedings. Thank you.
Congratulations to all the contributing authors. This volume is a testament to your intellectual curiosity and hard work. As we prepare to the transition to the scientific sessions, it's time to express our collective gratitude. Now I invite Mr. Indranil Disanayake, the Secretary of URSAE 2025, to deliver the vote of thanks. Over to you, sir.
Good morning, ladies and gentlemen. As we conclude the inaugural session of 4th Undergraduate Research Symposium on Agricultural Engineering and Environmental Technology, it is my privilege on behalf of the organizing committee to propose the vote of thanks. First and foremost, I extend our sincere and heartfelt gratitude to our distinguished keynote speakers for graciously accepting our invitation and for sharing their valuable time, expertise, and insights during this inaugural session. Your combination have set a strong academic foundation and provided inspiration for the technical session that will follow. We are deeply thankful to Professor Shinichiro Kuroki of Kyoto University, Japan, for delivering the main keynote address, which has given clear direction and intellectual depth to the theme of the URSAE 2025. We also extend our appreciation to our session keynote speakers, Professor Bam H.N. Rasapindre, Engineer Indunil Subhashana, Professor Dali Roy T. Mantoben, and Dr. K.P.P. Udegi for their commitment and readiness to contribute to the forthcoming technical sessions. We express our profound appreciation to the Dean of the Faculty of Agriculture, University of Ruhuna, Senior Professor Guttila Yugantha Jayasinghe, for gracing the inaugural session and for his continued encouragement and unwavering support in organizing and sustaining this symposium. Our sincere thanks are also extended to the Head of the Department, Agricultural Engineering and Environmental Technology, Dr. M.G.G. Avanti, for her leadership, guidance, and unwavering support in organizing and sustaining this symposium. I would also like to acknowledge with gratitude our session chairpersons, Professor S. Vijayatunga, Mrs. Chinta Rupasinghe, Dr. B.M.S. Jinendra, and Dr. Anushka Bandara, who will be guiding the technical session and facilitating meaningful academic discussions throughout the day. Our sincere appreciation goes to Editor-in-Chief of the URSAE 2025 proceeding, Dr. Praneeth Ruwan Pathirana, for his dedication and effort in ensuring the academic quality of the symposium publication. I would like to warmly acknowledge the effort of the symposium coordinator, Dr. KMTS Bandara, whose leadership and coordination have been instrumental in bringing URSAE 2025 to this stage. We gratefully acknowledge the contribution of all session conveners, whose carefully planning and coordination will ensure the smooth conduct of the technical session. A special word of thanks is extended to the Fountain Project team for providing essential technical support, enabling the seamless delivery of this virtual symposium. Our appreciation is also extended to all research supervisors, academic and non-academic staff, and organizing committee members whose effective effort have made this event possible. Finally, I would like to thank our student presenters, and I encourage you to actively participate in your respective technical session and discussion as we proceed. As we now move forward to the technical session, I invite all participants to encourage actively, share insight, and make the most of the discussion ahead. On behalf of the organizing committee, I thank you all once again for being part of the inaugural session of URSAE 2025, and I wish you productive and enriching symposium. Thank you all.
Thank you, sir. This marked the official conclusion of our inaugural session, followed by the national anthem.
Siri Barini, Surendiyati. අප ශක්ති අප හද තුල භක්ති ඔබ අප ආලෝකේ අපගේ අනුප්‍රාණේ ඔබ අප ජීවන වේ අප මුක්තිය ඔබ වේ නව ජීවන ගෙනිනේ නිදින අප පුබුදු කරන් මාතා ඥාන වීර්ය වඩවමින රැගෙන යනු මන ජය භූමි කරා එකමවකගේ දරු කැළඹැවිනා යමු යමු වී නොපමා ප්‍රේම වඩා සැම වේද දුරැනදා නමෝ නමෝ මාතා අප ශ්‍රී ලංකා නමෝ 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 මාතා අප ශ්‍රී ලංකා නමෝ 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 මාතා.
The inaugural session of URSAE 2025 is now officially concluded. The technical sessions will now commence promptly at 10:15. Dear participants, please proceed to your designated sessions as per the schedule. I wish you all the day of stimulating discussions, fruitful networking, and profound discovery. Thank you.